12 men have walked on the moon. Nobody has since 1972. The rocks they brought back sat untouched in storage for over 50 years. Then a team at Oxford, with no new mission and no new samples, decided to reopen those old rocks anyway. Something inside them didn't match what anyone expected. The race. Nobody was sure America could win. In May 1961, President John F. Kennedy stood in front of Congress and promised the United States would land a man on the moon and bring him home safely before the decade was out. At the time, America had barely managed 15 minutes of human spaceflight. The Soviet Union had already put the first person into orbit weeks earlier, and NASA engineers had no proven rocket, no lunar lander, and no real plan for how astronauts would actually survive the trip. Kennedy originally estimated the whole effort would cost around $7 billion. By the time astronauts actually reached the moon, that number had already tripled. And by the program's end, it had climbed past $25 billion, more than $150 billion once adjusted for today's money. That price bought the Saturn V rocket, standing 363 feet tall and weighing over 6.5 million pounds fully fueled, along with a lunar module and command module built from scratch with no earlier design to copy from. Apollo 11 landed on the moon on July 20th, 1969, with astronauts Neil Armstrong and Buzz Aldrin stepping onto the surface while Michael Collins orbited above in the command module. It happened with less than 5 months to spare before Kennedy's decade deadline ran out. The goal that once sounded almost impossible had been reached, and NASA had proven in under a decade that landing humans on another world was actually achievable. That success looked like the beginning of something much bigger. Nobody at NASA in 1969 expected that mission to be one of only a handful the agency would ever complete. What happened over the next 3 years is where the story gets far less triumphant. The only 6 landings anyone has ever made. Between 1969 and 1972, NASA landed astronauts on the moon 6 separate times, through the Apollo 11, 12, 14, 15, 16, and 17 missions. Apollo 13 was supposed to be a 7th landing, but an oxygen tank exploded on the way there, forcing the crew to loop around the moon without landing and limp back to Earth in a mission NASA still calls a successful failure. In total, 12 men walked on the lunar surface, and every single one of them was an American man, since no other country has ever landed a human on the moon. Each mission got more expensive than the last, as NASA pushed for more ambitious science. Apollo 11 cost about $355 million on its own, with the Saturn V rocket alone accounting for more than half that price. By the time Apollo 17 flew, the final 3 missions, upgraded to carry lunar rovers and stay on the surface far longer, were running closer to $450 million each. That steady climb in cost, happening while public excitement was fading fast, became one of the clearest warning signs that the program's days were numbered. Those 6 missions brought back roughly 382 kilograms of moon rock and soil, a haul that remains the largest collection of extraterrestrial material ever gathered by human hands. Apollo 11 alone returned about 48.5 pounds of rock and dust, material later valued at over $1 billion, given how rare and scientifically important it turned out to be. Scientists have been studying those same samples for over 50 years, and they still make up the majority of all lunar material available on Earth today. Every landing site, though, sat clustered in a narrow band near the moon's equator, on flat volcanic plains called Maria, because those areas were the easiest and safest places for a small spacecraft to touch down. That detail, landing only on the easiest terrain, sounds harmless on its own. It turned out to shape almost everything scientists thought they understood about the moon for the next 5 decades in a way nobody realized until very recently. The argument that never got settled. For decades, planetary scientists have argued over one basic question: did the moon ever have a real magnetic field? Today, the moon has none at all. No protective magnetic bubble like the one surrounding Earth. Yet many of the Apollo rock samples came back strongly magnetized, some carrying signs of a field comparable to Earth's, or even stronger. That contradiction confused researchers for a long time. A small rocky world like the moon has a tiny core, only about 1/7 of its total radius, and most models suggested a core that small could never generate a magnetic field anywhere near as strong as what some of the rocks seemed to show. Either the models were wrong, or something about the rocks themselves was misleading scientists. Some researchers leaned on the strongly magnetized samples as proof the moon once had a powerful global field. Others pointed to the small core and insisted that was physically impossible over long stretches of time. Nobody had a clean way to settle it, because every rock sample available for testing had come from the same 6 landing sites, all clustered in the same narrow strip near the equator. That limitation sat quietly in the background of lunar science for over 50 years. Meanwhile, orbiting spacecraft kept mapping magnetic anomalies across the wider lunar surface from a distance, without ever being able to physically test the rock underneath most of it, since no lander had ever touched down there to collect a sample. That gap between what orbiters could see and what scientists could actually hold in a lab stayed unresolved for decades, until a team decided to look at exactly why those particular rocks kept coming back magnetized in the first place. The team that went back to old rocks. Researchers at the University of Oxford's Department of Earth Sciences revisited the Apollo sample archive and charted something nobody had directly compared before: how much titanium each rock contained versus how strongly magnetized it was. The pattern that emerged was clear and consistent. Rocks with less than 6% titanium content showed weak magnetic signatures. Rocks with higher titanium content showed dramatically stronger ones. That single comparison exposed a sampling bias nobody had accounted for. All 6 Apollo landing sites sat on titanium-rich basaltic plains, the exact kind of flat, stable terrain that made those spots safe to land a spacecraft on in the first place. Astronauts, without ever realizing it, had spent 50 years bringing home a skewed sample, one made almost entirely of the rare rock type most likely to record an unusually strong magnetic signal. Computer modeling backed this up. If Apollo astronauts had collected rock at random locations across the moon instead of only from titanium-rich Maria, they would have been unlikely to capture evidence of any strong magnetic activity at all. In other words, the rocks that shaped 50 years of scientific debate weren't a typical sample of the moon. They were a rare and unusual slice of it, gathered entirely by accident of where it happened to be safest to land. What the rocks actually show. Once the titanium bias was accounted for, the picture became far more specific. The moon's magnetic field was weak for most of its 4.5 billion year history, generated by a small core dynamo similar in concept to Earth's, but far less powerful most of the time. Occasionally, though, that field spiked to intensities equal to or greater than Earth's current magnetic field, in bursts that likely lasted only thousands of years or less before fading back down again. Paleomagnetic records suggest the strongest of these bursts happened billions of years ago, sometime between roughly 3.56 and 4.2 billion years ago, with a much weaker, low field period following for a long stretch afterward. Some traces of magnetization have even been dated to far more recent lunar history than anyone expected, hinting that some form of magnetic activity may have persisted on the moon on and off far longer than older models predicted. This means the Apollo astronauts, without knowing it, happened to grab exactly the type of rock most likely to preserve a memory of the moon's rare, dramatic magnetic outbursts, while missing almost everything about its calmer, more typical state. That single insight rewrote what scientists thought a normal moon rock actually represents. And it matters for understanding planetary cores in general, since magnetic fields like this help shield a world's surface from the sun's radiation. But the reason nobody sampled anywhere else on the moon has nothing to do with rocks at all, and everything to do with what happened back on Earth. Why NASA stopped sending people at all. By 1970, NASA's budget was already shrinking fast. The agency's funding had been cut year after year since 1967, as the Vietnam War, urban problems, and other domestic priorities pulled money and public attention away from space. A month after Apollo 12 landed in November 1969, one of President Nixon's top aides told NASA directly that the president did not have enough money in the near future and had to accept limits on space activity. NASA's budget shrank by 15% almost immediately afterward. Then, in April 1970, Apollo 13's oxygen tank exploded en route to the moon, turning what should have been a routine landing into a life-threatening emergency. The crew survived, but the near disaster shook confidence inside NASA itself. Attitudes at the Johnson Space Center shifted toward caution, with officials reportedly favoring quitting while ahead rather than risking a mission that could strand or kill astronauts on the lunar surface with no backup plan, since the lunar module's single ascent engine had no backup if it ever failed to fire. Facing both tightened budgets and heightened safety concerns, NASA canceled the final 3 planned Apollo missions in 1970, ending the program 2 years earlier than originally scheduled. Apollo 17 became the last crewed mission to the moon, landing in December 1972 and carrying astronauts Gene Cernan, Harrison Schmitt, and Ron Evans. The canceled flights freed up funding and hardware for other programs NASA wanted to pursue next, including Skylab and the developing Space Shuttle. With America's original goal already achieved and public interest fading fast, there was no longer enough political will to keep funding lunar landings. The irony is that the later missions had produced some of the richest science of the whole program, including deeper drilling, longer surface stays, and the use of a lunar rover right at the exact moment funding ran out to keep doing more of it. The 50-year gap nobody closed. Since Gene Cernan left the last boot print on the moon in December 1972, no human being has returned to its surface. Several U.S. vice presidents, including George H.W. Bush, Dan Quayle, and Mike Pence, have publicly promised a return to the moon over the following decades. None of those promises turned into an actual crewed landing. Public opinion played a role in why those promises kept stalling. One national poll found only 8% of Americans actively wanted to see astronauts return to the lunar surface, even though people generally view the Apollo program itself with pride. Space policy researchers have pointed out that politicians get plenty of attention simply from announcing a return to the moon without needing to follow through on the enormous cost required to actually fund one. That gap between promise and follow through stretched across 5 decades, all while the same 382 kilograms of Apollo rock sat in storage, waiting for someone to look at them differently. Other missions kept adding small pieces to the puzzle from a distance during that time, but none of them physically returned a person or a fresh handful of surface rock to compare against what Apollo had already collected. The missions that are finally changing the picture. Since Apollo ended, other missions have kept adding pieces to the puzzle without ever landing another human on the surface. Orbiters like Lunar Prospector and Grail mapped the moon's magnetic anomalies and gravity field from above, giving scientists global data that Apollo's ground samples alone could never provide. In 2024, China's Chang'e 6 mission returned the first ever samples collected from the moon's far side, an area no Apollo mission ever reached, since every crewed landing stayed on the near side. Analysis of those far side samples found signs of a possible rebound in the moon's magnetic field strength around 2.8 billion years ago, adding yet another data point about how the moon's magnetic activity rose and fell over time in ways scientists are still piecing together. That single mission already told researchers something Apollo's 50 years of near-side sampling never could, simply by reaching a part of the moon nobody had physically touched before. NASA's own Artemis program is now aiming to send astronauts back to the lunar surface, with planned landing sites near the moon's south pole, a region no Apollo mission ever got close to, chosen partly because of suspected water ice hiding in permanently shadowed craters there. If astronauts eventually collect samples from that region and other unexplored parts of the moon, scientists will finally have material that is not clustered entirely on titanium-rich equatorial plains. That would give researchers their first real chance to test whether the rest of the moon tells a different story than the one Apollo's narrow sampling accidentally created, more than 50 years after the last person walked away from it. The verdict. The moon wasn't magnetically dramatic the way 50 years of Apollo data suggested, and it wasn't quietly forgotten because there was nothing left to learn either. Astronauts brought home a biased sample without ever knowing it, and budget cuts back on Earth ended the missions before anyone could correct that bias with a wider search. Both mysteries only got solved because someone finally went back and looked at old material with fresh eyes, decades after everyone assumed the story was already complete. If you enjoyed this video, make sure to subscribe, and I'll see you in the next one.